Simple carbohydrates contain only C, H, and O and have a carbonyl group and an alcohol group. These carbohydrates may exist in open-chain form but are often converted to cyclic form. This conversion occurs by the attack of the nucleophilic oxygen in the alcohol group on the electrophilic carbon in the carbonyl group. More complex carbohydrates can incorporate amine, amide, or sulfide dioxide groups. In this conversion, the alcohol oxygen becomes part of the ring. The carbonyl from the carbonyl group, known as the anomeric carbon, becomes the first carbon in the ring. This anomeric carbon can join with the alcohol group of another sugar, forming an O-glycosidic bond. In these carbohydrates, the glycosidic bond is formed between the anomeric carbon of one sugar and the nucleophilic nitrogen of an amine or amide, N-glycosidic bond, or the nucleophilic sulfur of a sulfur dioxide, S-glycosidic bond. Alpha-1,4 linkages favor bent structures and are utilized in compact storage. For example, glycogen is a highly branched polymer of glucose that is utilized as energy storage in the liver. Beta-1,4 linkages, on the other hand, favor straight chains. Cellulose is formed from long chains of glucose joined by beta-1,4 linkages and do not branch. Cellulose is insoluble in water, but glycogen is moderately soluble due to its many branches. Carbohydrates are OH-rich, water-soluble molecules that serve as food for humans and their cells. While carbohydrates can exist in open-chain form, they prefer to form cyclic structures because they are lower in energy. Aggrecan is a proteoglycan that, when linked with collagen by hyaluronate, forms cartilage. The aggrecan units in cartilage are negatively charged, attracting water. This allows aggrecan to serve as a shock absorber or cushion. Cartilage is a tough but flexible tissue that joins bones together. The water-absorbing property of aggrecan units helps to give cartilage its consistency, and the cushioning property of the aggrecan units reduces friction between bones. So, what's the TLDR? Carbohydrates are OH-rich organic compounds and tend to form cyclic structures for stability. They serve as quick sources of energy for the cell, but they can also be stored in the liver as glycogen for later use. Using carbohydrates as fuel for the body prevents proteins from being used for this purpose and enables fat metabolism. Different bonding between carbohydrate molecules leads to different functions. Glycogen has alpha linkages for storage, and cellulose has beta linkages for structural integrity. Additionally, carbohydrates can combine with other molecules to build macromolecules that serve various other functions in the cell, like reducing friction between joints. With all that said, let's get this bread.